Hi everyone, welcome back to Gratuitous Math. So this is the second video in the little mini series on linear functions. So in the last video we looked at the standard linear function, so your y equals ax plus b, which is the general version, which we call the partial variation. It has a non-zero rate of change and a non-zero initial value. So this is where your line crosses through an initial value and it has a rate of change. So it is actually changing for every x value. And we looked at the special case of the constant function where your rate of change is 0, which ends up giving you just y equals a number, which means that your function just looks like a straight horizontal line at y equals a number, and it is not changing for every x value. There's no vertical change happening. And then we looked at the last special case, so your direct variation, where your initial value is 0. So this just ends up being y equals your rate of change times your x, and you don't need to put in that initial value since it's 0, and that results in a line going directly through the origin and having a change for every x. But your starting point is 0 in this case. So now that we kind of understand the special cases, I wanted to take a closer look at what happens when you start playing around with your rate of change and with your initial value and how that affects the way that your function looks. So I have a couple screenshots here prepared. So here we have kind of the function that we are working with, that same line from the last video, so our 4x plus 5. So that is in green. And I'm just going to make it a little bit more clear here. So, or actually, I think it's clear enough. So we have our green line, and that's what we're familiar with, right? So it goes through 5, and then every time you go across an x, you go up by 4. So if I kind of zoom in here, you can see that a little bit. When you go across by 1 square, you go up by 1, 2, 3, 4. So that change of across by 1 and up by 4. So you have that as a rate of change. I'll just get rid of that. And then what I did was I changed only the rate of change. I did not change the initial value. I left that at 5 and I doubled the rate of change to 8. So what ends up happening to your line here is it becomes steeper. It goes closer to that vertical axis. But by not changing the initial value, the starting point is still at 5. So you're still starting at 5. It's just now, I should have not erased that, so I'll leave that back there. So now instead of going up by 4 for that one across, this blue line is going up. So that's 5, 6, 7, 8. It's going up by 8 for every one square that it goes across. So that change is plus 8. So you have a greater rate of change. Okay, so that's what happens when you change the rate of change so that a value in the standard function. So you look at this, y equals ax plus b. So changing this one affects steepness. Is that the right steepness? Anyway, so you can have things that look like this, things that look like this, things that look very kind of not changing by very much. So that's what changing A will do. And now looking at what changing B will do. So here again, our green line is the one that we've been working with, so that 4x plus 5. And I've added in this red line, which is 4x plus 15. So I've now changed the initial value from 5 to 15. So what ended up happening here is if I kind of draw right over this green line, so we get the same green line, what ended up happening is that the line was kind of picked up and just slid over. So the steepness did not change. It was just slid over so that now it starts at 15 instead of starting at 5. But the steepness and the angle of that line remains the same. So we look at our y equals ax plus b. So changing this slides the line over to a new initial value. And you'll actually notice something special about these lines is that they are parallel. They actually will never touch. And that's because their slope is the same. Hint, hint, that will become very important next year. But it's just something cool to see. Okay, and then the last special case that I wanted to look at is when you have the exact same kind of rule, except one rate of change is positive and one is negative. So what happens here is that the steepness of these lines is actually exactly the same. If you were to calculate the angles, they would have the same angles, just kind of in a reverse order, right? So if I look at, like, oops, I'm trying to zoom in. Okay. So if I looked at the angle where my red line crosses my x-axis, and then the angle where my green line crosses the x-axis, they will have kind of similar angles. So this one and this one would be the same, and then this one and this one would be the same. And it's just because they're kind of crossing in different directions, but the way that they are steeped is the same, just kind of in a reverse order. So what happens here is that, so y equals ax plus b. So here we're in this example, we're looking at what positive and negative does. So positive, negative, a positive slope will have an increasing line. So we'd be going up like this. And a negative will have a decreasing line. And it will be going down like this. And just so that you can see that the number there, so the actual value, the 4, that has to do with the steepness, and it's the sign that has to do with the direction, whether it's going upwards or whether it is going downwards. The number has no effect on it going up or down. That's really the positive or the negative that affects that. Okay, and was there anything else that I wanted to show? Just thinking. Nope, I don't believe there was. Oh, actually, there is. Since you notice that it's positive and negative, that affects the decreasing and increasing, and it doesn't actually affect how something is steep, you might be wondering, how do I make a line that is really, really close to the x-axis, that's really horizontal, right? Since we've kind of seen that, and I'll just pull up my graphing calculator so you can see this a little bit. So I'll just delete these, delete. So if we wanted to just put in y equals x plus 5, so instead of x plus 4, I'm just putting x. So we're going up by 1 for every one we go across. So you might be thinking, well, if making this negative doesn't, it just kind of flips it so that it's going downwards instead of upwards, well, how do I make this more horizontal? How do I decrease the steepness if 1x like how do you go more down than that? And the answer is that you need to use a fraction. So in order to go more horizontal, you need to use a number that's between 0 and 1. So the smaller your fraction, the smaller your rate of change. So if you wanted to put in 1/2, that would give you a much less steep line or a flatter line. Another one that you can do is y equals 1/4x. We'll leave it at +5. So the smaller your fraction, the more horizontal your line is. So you can even go 1/10x. That would be even more horizontal. So really that's just to show that it's really the number next to x that affects the angle of it, and the positive negative is really just that increasing or decreasing. So if I decided to put a negative in here, then it would start decreasing. Okay, so I encourage you to play around with these graphing calculators and kind of get comfortable in figuring out how to change and manipulate your linear function to make it look different. And that is all. All right. Thanks for tuning in. Remember to hit that subscribe button, and if this video helped you, you can also hit the like button, and don't forget to turn on the little bell so you get notified for future videos. Bye for me.